It's not doing option A through 1,000. It's not doing that. What it's taking is data, millions and millions of pieces of data, such as data from strands of proteins, and putting it together into what it thinks will happen to those atoms to make a new medicine or to make this new device or this new thing. Like taking traffic patterns and blending in millions and millions of pieces of data from around the world of varying sizes of cities and blending it together.
Let's go back to whenever the very first computer was created, the first binary ones and zeros. Mm-hmm. The computer I have in front of me right here, would this computer have more in common with that or with the quantum computer?
Absolutely, with the old one. The original. This is a totally different way. Think about this way. We're going to go with that computer is a car driving on the street. Quantum computer is a boat in the ocean floating around wherever it wants to go. And then that's where we're at now. Quantum computing in 10 years will be like a submarine. Not only can it go anywhere it wants on the surface, but it can go anywhere down into different levels of things it can do.
Are quantum computers sort of like nuclear bombs that at this point only governments have them and not every government has one, or are they more prolific than that?
Well, they will be more prolific. They will be like everybody having a cell phone in the way long off future. In the long off future. Right now, IBM has the fastest. To put it to you this way, in order to break all the encryption on the internet, and all the encryption that credit cards use to make transactions, you would need one. No, so let me back up. A bit, obviously, there's a one or zero. Quantum computing runs in qubits. So they just put a Q in front of it. In order to crack all the encryption on the internet right now today, you would need 1 million plus qubits in order to do that.
Okay.
Right now, IBM, again, has the fastest quantum computer, and they're only at 433. So there's a lot of green grass between 433 and 1 million plus. Mm-hmm. There's a long way to go. Now, will it take forever? No, it'll probably take 7 to 10 years, which doesn't sound like a long time, honestly, but that's what IBM's predicting.
And I am anticipating not understanding your answer to this, but what gets us from 430 to 1 million? What do they need to fill that up with?
That is all going to be about the technology of two things: miniaturization. It's going to come down to how, because they keep adding this. Remember, the amount of power it takes to keep a 433-bit is a room full of refrigerators.
Yes.
Okay, so if you keep adding more power to that, you need bigger refrigerators. So they're going to have to figure out miniaturization of the processing power in order to keep the refrigerator small, or you're going to have nothing but a giant building of refrigeration units just to keep the processors cold enough.
Real question. Why don't they put the quantum computers in space, where it's already that cold and you don't need to build the refrigeration?
So you'd have to get right now, the way to transmit that data wouldn't even be fast enough to get information to and from that computer. So on top of that, outer space isn't even 459.
It's not cold enough.
No, outer space is not even negative 459 degrees Fahrenheit. So right now, that is the technology that is changing. They're getting better at it every year. What's really crazy is that, in 5 to 7 years, you remember the arms race back in the 80s that we were all having with countries? The new race now is who can get to 1 million qubits in a quantum computer. Because when that happens, there's no more encryption that exists today.
Over.
Well, not game over. Now, here's the other thing that's interesting. In less than 5 years, you're going to get a different type of encryption in your credit card, your banking, everything. All encryption is going to start changing. And they're calling it Q-safe, and so your new encryption will be called Q-safe. So that's coming down the line. That is to combat the potential of quantum computers actually being able to crack every bit of encryption out there. So imagine what now would take literally millions of years to crack is the hardest encryption. We're talking military-grade encryption would take millions of years to crack now. Quantum computer at 1 million qubits would take about an hour.
So if we have one, and China has one, and Russia has one, won't we just be breaking into each other's stuff constantly?
Unless the encryption keeps up. So that's going to be the battle. There's your new.
So it's just going to be a bigger version of what we're doing now.
Correct. But it has to happen in a faster way.
And so just like the Manhattan Project, let's say China got there 2 years before us.
Yes.
They could run the table.
Absolutely. You could, because you'd crack all the encryption. You would be able to. There would be no more digital encryption. But again, we're a long way between 433 and 1 million plus in qubits. So. But that's the new arms race is not arms anymore. It's quantum computing.
I understood all of that enough to scare me. You feel me?
I mean, it has to sound, when you're listening to that, I know it's not a weapon, but it sounds like the difference between a regular old bomb and a nuclear bomb.
Yeah.
Right. Correct.
In terms of the practicality of the, what do you call it, the proportions.
Yeah.
It's like trying to, who gets to figure out the Enigma machine first? The Germans had the Enigma machine.
Yeah, that made my head hurt too.
So anyway, I thought, I had a bunch of people asking me to give a little more insight in quantum computing. I thought I'd throw that out, and I've got some other really fun things that are out there is based on time. But one thing I know that's coming is the Echo, the Google Home, and the Apple Home are about to use AI for real. So you'll be able to stand in your home. To give you an idea of how cool this is, I just want to give you a scenario. Imagine your kids having a little sleepover. So you tell the Echo or Google Home, what have you, my son is having 6 friends over. They're 9 to 10 years old. 1 is a vegan. Okay, 2 are lactose intolerant. I need a dinner for all 9 kids. I need snacks for a movie, and I need breakfast for when they wake up. Order it, and it will just do it and send it to you that day. So that's the kind of thing where you're not searching for individual things anymore. That's just a practical example of how AI will start to impact us in the next 3 years.
So we're getting to the point of like true sci-fi.
Yes.
The stuff that we grew up thinking that like that's what we would have today.
Yes.
We're really going to have that.
We're really going to have that. Absolutely.
I want the Jetsons kitchen.
I mean, it sounds like this is what it's going to be.
I know. That sounds amazing. 3D printed. Boom. Let's go.
I love it.
Why does this scare me more than excite me?
Because it's opening up a Pandora's box of like, if encryption is going away, then privacy goes away. There's all these, there's for every positive possibility, it seems like there's a negative.
It's that
flip
constant
side,
battle.
so-
But I would also bet that people, if you told people 100 years ago about these cell phones and what you can do with them, they'd be like, I don't like that.
Yeah.
Yeah.
You could just walk around with a camera on me all the time.
Yeah.
I'm like, I think.
Yeah.
But God, you're right.
Yeah.
It's confusing.
All right. To talk to George about practical applications of all this for your business, go to throttlenet.com/DGS. Thank you. Have a great weekend.
Thank you. You as well. Happy
All right,
Labor
pal.
Day.